All right, class, today I want to talk about something called velocity. But before we get there, I want to ask, how many of you have ever taken a road trip? Maybe with your family, with the school, gone on a field trip down to Salt Lake, or maybe some of you have traveled really far, like across the country. Well, there are many conversations that go on within the car, but I think the most frequently asked questions on a road trip are from the kids in the back seat, and they want to know, are we there yet? Or how much longer? These are excellent questions, and today we're going to learn how you guys can answer those questions for yourself. How much longer? But first, we're going to take a few minutes, and within your partnerships at your table, I want you to discuss, what do you know about traveling in cars? What do you know about the physics of traveling in a car? So go ahead and discuss that for a few minutes. All right, great. I heard some great comments, and some of the comments that stood out to me are things like braking slows down a car, accelerating speeds up a car, you're supposed to go the speed limit, I heard speed is measured in miles per hour, travel time depends on the distance you're going, so a longer distance, a longer travel time, a shorter distance, a shorter travel time. And the faster you go, the quicker you get there. All right, so from what you've just discussed, we're going to now start an investigation. Okay, so in groups of 3, you're going to determine the relationship between speed, distance, and time. Okay, so I'm going to give you some materials. One is going to be a little wind-up car, or in some cases a caterpillar, because I am out of wind-up cars. And you're going to simply experiment with it and gather data on the distance and the time that the distance it can go and the time it travels. So this is something I want you to simply investigate. I'm not going to give you a lot of details on how to do this, but I would like you to get out a sheet of paper and write down a few important things. For example, what is your hypothesis? What do you think is the relationship, and what's an objective? How are you going to find that out? Okay, I also want you to write down the different variables you are looking at. What are you manipulating? So that would be an independent variable. And then also the dependent variables. What are you measuring? Okay. Then also jot down your observations, the measurements you find, and then once you've gone through some investigation, I want you to evaluate your findings. And our goal with this is to set up an equation showing the relationship between speed, time, and distance. And then we'll discuss this as a class. So go ahead and work within your groups. So here is an example of how the investigation would go. Students would use a small wind-up toy or something like that and just take measurements. All right, great work. I heard a lot of discussion, a lot of thinking. I'm really excited about what we found. And so from what I saw and what I heard, I want to discuss our findings, okay? I heard some people talk about how their caterpillar went faster on a hard surface than on carpet, or one of the groups said the ones that went a farther distance in 10 seconds were traveling faster than the ones that went a shorter distance in 10 seconds. And so, from all of this, I noticed you guys came up with the relationship. So the speed of the caterpillar is the centimeters it went over the seconds it took to get there, or distance is speed over time, which comes to the big equation: speed is distance over time. I was really pleased to see how well you guys did at finding the relationship between speed. So now I want to talk a little bit more about the relationship. The motion of objects is a fundamental piece of physics called kinematics, and we're going to go a lot deeper into kinematics throughout the next couple weeks. Kinematics, like I said, is how objects move. Okay? And speed is the rate at which objects are moving, the rate at which objects travel. And so that rate is in an equation which is speed equals distance over time. Okay, and now with that knowledge of speed, we're going to answer a question. This is actually quite related to us. Next week our football team is going to the state playoffs, and I want to congratulate any football players here. And the school is providing bus transportation for students that are interested in going. So I want us to answer the question, how long will this trip take? And what is the latest we could leave in order to be on time for the 3 p.m. kickoff? Okay? So what we know is, according to a map, it's 84 miles to Rice-Eccles Stadium. That's where the playoffs are going to be. And the average bus speed is 60 miles per hour. Okay, so let's go through this together. Let's work through this together. And if someone could help me write this on the board, that'd be great. So first, let's write down what we know. We are looking for our time, and we know that our distance is 84 miles, and our speed is 60 miles per hour. Okay? So when we manipulate our speed equation, we can solve it for time. And so time is the distance over the speed. Now we're going to plug in our values. And our time is 84 miles, or our time equals our distance, 84 miles, over our speed, 60 miles per hour. And so our miles cancel out there, and we have 1.4 hours. And when we convert that into minutes, we know that it is 1 hour and 24 minutes to Rice-Eccles Stadium. Okay? And so the latest we could leave is 1:36. But don't show up at 1:36, because I believe as a school we're going to be leaving a little bit earlier. Anyway, so great. Now you guys are able to answer this question, how long until we get there? So next time you're on a road trip, you can check out those mile signs and see how far it is to your destination, or you can see how fast you're going, and you can find out for yourself how long until we get there. Okay, great. So now I just want to go over some old and new vocabulary. We've been using the term distance, but I want to distinguish the difference between distance and displacement, because from now on we're going to be using displacement as our term for distance. And there's a few differences here. Distance is just a magnitude of how far, right? And displacement is more than that. It's not only how far, but also what direction. So, for example, 84 miles south is a lot different than 84 miles north. and we have to be able to distinguish that in some of our calculations. Okay, and so you can get the distance. When I say it's a magnitude, it would be the absolute value. So a displacement can be positive or negative. It could be a negative 84 or a positive 84, but a distance is just the magnitude, so it would just be 84. And then it's very similar with speed and velocity. Speed is just a magnitude. It is the absolute value of velocity. And velocity includes the rate at which an object changes position. It is not only speed, but also direction. It can be positive or negative. So, and we measure that in SI units. Alright, thank you so much for listening, and have a great day.